Is there a way for non-specialists to understand complex scientific claims, or do they just have to trust experts on faith? I would say that non-specialists are not forced into blind faith. There is a practical way to evaluate scientific claims without being a technical insider. You cannot rederive the math, but you can audit the structure of the claim. Think of it as systems-level literacy rather than equation-level literacy. Here is how that works. 1. Separate evidence from interpretation. Most public disputes are not about raw data. They are about what story is being told about the data. Data are measurements. Models are stories that try to explain those measurements. You do not need to be a physicist to ask, is the data directly observed or indirectly inferred? Does the model explain more than one independent dataset? Does the model make risky predictions that could fail? Have those predictions actually been tested? A claim that explains many unrelated observations with one mechanism has much higher credibility than one that only explains what it was built to explain. 2. Look for prediction, not narration. Strong science predicts new facts before they are observed. Weak science explains old facts after they are already known. You can always ask, did this model successfully predict anything before it was confirmed? Or does it mainly reinterpret existing observations? Prediction is harder than explanation. It is also much more reliable. 3. Check for independent replication. If a claim is real, different groups should be able to observe it using different methods. You do not need to understand the instruments. You only need to check, are multiple labs reproducing the result, or is it concentrated in one research circle? Are failed replications openly discussed? A claim that survives hostile replication attempts is far more trustworthy. 4. Watch how uncertainty is treated. Certainty is good science speaks in ranges, limits, and error bars. Weak science speaks in certainty and slogans. If a field regularly says, this is unresolved, this only works under these conditions, this might fail if, that is a healthy sign. When a field speaks in permanent final answers, confident slogans, or moral pressure, caution is warranted. 5. Follow the incentive structure. This is critical and often ignored. Ask, who funds the research? Who benefits if the claim is accepted? Who loses if it is rejected? Science is done by humans inside institutions. Incentives shape what is studied, how results are framed, and what is amplified. You do not need technical training to see incentive pressure. 6. Understand what consensus actually means. Consensus does not mean proven, it means a dominant model currently organizes most research. It works better than competitors so far. It may still be incomplete or wrong in parts. Consensus is a working agreement, not a truth certificate. Bottom line, you are not meant to recalculate physics or chemistry. You are meant to audit predictive power, replication, scope of explanation, treatment of uncertainty, incentive structure. That is how non-specialists can stay rational without blind trust, not by mastering equations, by mastering how science actually functions as a system. Thanks for watching.